This is Ujjal, and I have come up with a new topic. It's on shift operators in Java, C, and C++. So let's start on this. So there are three operators: signed left shift, signed right shift, and unsigned right shift. Signed left shift and signed right shift operators are available in all three languages: C, C++, Java. The unsigned right shift operator, I believe it's available only in Java. So let's try to understand what signed left shift operator is. So on the left side, the number capital N, and right side it is small m. So it means that the bits, the binary representation of n is going to be shifted by m bits on the left side. Okay, so it is better say, instead of binary representation, memory representation, how it is stored in memory. So that representation is shifted by m bits on the left side when we are performing signed left shift operator. Similarly, when we are performing signed right shift operator, then all the bits including sign bit, it moved by m bits on the right side, but at the same time the sign bit is also maintained in its position. So it means it maintains the sign. That's why it's signed right shift operator. We'll see with example to understand it in more details. Now let's move to the last one. This is unsigned right shift operator. So it is all the bits are going to be shifted by m bits on the right side, but and at the same time the sign is not going to be maintained anymore. It would be filled with 0. Okay. Similarly, when you are performing left shift operator, right, that time the rightmost bit is filled with 0. Okay. Only case of signed right shift, we maintain the sign and we don't fill it with 0. Okay, so with this understanding you can see, right, signed unsigned left shift operator, it is not at all needed because we are going to have the same result as signed left shift operator all the time. So that's why that is not there. Okay, now directly jump into the example. So okay, let's apply different shift operators on number 11. So I have given the memory representation of number 11 here. Okay, so when we are performing right shift by 1 bit, so if you see, they moved by 1 bit and now the number became 22. So it is seen that it is always going to be double. Okay, as long as the number after shifting it is fitting into the positive numbers range, it is going to be double. So similarly, let's take a right shift operator, shifting it by 1 bit. If you see, we are maintaining the sign here. We are moving all the bits by 1 bit on the right side. At the same time, we are maintaining the sign. The 5 become 11 become 5 now. It is like dividing 11 by 2 to the power 1. So integer division become 5. You can think of like that way. Okay, so yeah, now when you are performing unsigned right shift operator, you can see we are not maintaining the sign here, we are replacing it with 0. But in case of positive number, it was earlier also 0, here also it is 0. So right shift, signed right shift and unsigned right shift are same for positive numbers. Okay, let's take a negative number. Let's take negative number minus 11. Okay, so this is the representation. The first bit represent sign bit, and this certainly not 11 because if you are confused, this is stored, all the negative numbers are stored in 2's complement method, using 2's complement method in memory. Okay, so minus 11 is actually sign bit and 2's complement of 11. That's how it is stored in memory. So if you want to get more understanding on how numbers are stored in memory, okay, this whole numbers, then I have a video on that. You can go and check that out. I'll give you that link with this video. Okay, now let's shift it by one bit on the left side. We can see it is moving this way, minus 11 become minus 22. When we are shifting it right side, then it is maintaining the sign here, if you see, and at the same time it is shifting all its bit. So minus 11 become minus 6. Now we are performing unsigned right shift operator. That time we are not maintaining the sign, we are filling it with 0, and as you can see, the negative number has turned into a big positive number because the negative sign bit is now replaced with 0. At the same time, right, when it is moving right leftward, that time also the rightmost bit is populated with 0. Okay, let's take another example. Here we are applying shift operator on 127. Why I have chosen 127? It's a boundary condition, because an 8-bit sign number can hold maximum 127 positive number. Positive number is 127 that it can store at max. Okay, so when you are moving this, it cannot be doubled this time. Okay, it's already in a situation where it can be doubled, because it is now overriding its sign bit. Okay, so yeah, left side is added 0, but now it has become a negative number because sign bit is overridden, and now it became minus 2. Okay, now when we are shifting rightward one bit, so that time it is maintaining the sign as usual, and now it is as usual, it is minus sorry, it is just half of it, integer division by 2, so 63. Yeah, now applying shift operator on minus 128. It is the lowest negative number that an 8-bit number can store. Okay, yeah, this is the sign bit, and this bit, as I told earlier, it's stored in 2's complement method. Otherwise you may feel like this is negative 0. It's not. Okay, so when you are performing left shift operator on it, okay, now everything becomes 0, so it's 0. When you are performing a right shift operator on it, okay, so it is becoming just half of it, it is maintaining sign. When we are performing unsigned right shift operator, and then it is moving all the bits by 1 bit. At the same time it is filling it with 0, so it is becoming a positive number. Now it is positive 64. Try to remember these things. We are going to run these things through program also to see whether these numbers are matching or not. But at the time of program, this ranges, right, we will not perform with byte, we will perform with integer, because when you are performing operation in C, C++ or Java, these whole numbers actually converted into integer, byte or short or integer, they all converted into integer, and then operation is performed. So that time we have plenty of spaces to move on the left side, so it is better to perform on this operation on integer while practicing. Okay, let's move to the last slide. Okay, now we are applying shift operator on 64. Why I have chosen this number? This number is having the maximum bit, which is not sign bit. Among the actual number bit, maximum bit is 1. So when you are making, turning into we're shifting it by 1, So it is simply overriding the sign bit and becoming a negative number. So this is one example where we are turning one positive number into a negative one. Earlier also we have seen one example. So yeah, at the same time, as you know, right, this is not always going to be 1. It could be any number which is an unsigned number. Okay, it could be any number which is an unsigned number. Remember, not a signed one. So when you are performing right shift operator, if you can see, it is right shifted by 3 bits. 64 became 8. Yeah, if you do any negative number, what will happen? You will get 0. Why you will get 0? Because when you are performing, you are putting it a unsigned signed number, right, with you give a number, but computer is going to consider it as an unsigned number with its first bit as 1. So you can understand, right, that's a very big number. And if we shift our digits by that many numbers, integer is having 32 bits, but if we move that many bits, so whether in either direction, whether it's in positive or negative, it is always going to be 0. So you can try that out. It is going to be 0 all the time. Okay, let's move to code editor. We'll perform these things over there to see whatever we are showing here are matching with the actual result or not. Okay, let's jump into that. Okay, let's start writing here. Okay, so I have already mentioned these things, their ranges, byte, short, int, long, because we are going to take this range. So that's why I have mentioned it here. Okay, let's run it. It's the first example that we are going to run here. We are shifting 11 on left side, right side, in signed and unsigned form. If you see, the numbers are exactly matching. When we are shifting on the left side by 1 bit, it is double 22, on the right side 5, and unsigned right shift, then also it is 5, because for positive number it's not going to change, it's only going to change for negative numbers. Okay, let's comment this out, let's uncomment this. Now we are going to perform the same operation on minus 11. If you see, now also it is behaving as expected. Minus 11 after left shift operator became minus 22, right shift operator became minus 6, and while performing unsigned right shift, you can see, right, it has turned into a big number. Okay, this number is big because when you are performing it, it performs on integer. Okay, here anyway you have taken everything as integer, so okay, let's uncomment it. Okay, this is the number, this is the max positive number that we can store in an integer, signed integer. Okay, let's perform this. Instead of byte, here we are performing it on integer. Okay, that's the only difference. Yeah, so when I shifted it right side, because it is already filled the highest number, so its sign bit got replaced. Okay, 0 got replaced with 1 and it became a negative number. On the left side, when you are moving, it's a positive number. When you are when you are doing right shift operator and unsigned right shift operator, in either case it is moving to this number. Okay, because it's a positive number, so these two operators are going to behave the same way. Output is always going to be same. Let's take the last one. Okay, this is minus number, and it is the lowest number, not the max. It is the lowest negative number that an integer can hold. Okay, let's perform the operation on it. Instead of smallest byte, we have taken smallest integer. Okay, here, that's the only difference. So yeah, when we are shifting it left side by 1 bit, it has become 0. That time also it was 0. When we are shifting it right side, it has become negative half of it. When we are shifting with sign bit 0, only the sign bit got changed, okay, from negative to positive, and now it has become positive number instead of negative. Okay, is there any more example? Yeah, okay, last two examples are also there. Okay, if you see here, I have taken a number where 31st bit, okay, 31st bit is positive. They are like the 7th bit over there, like, so yeah, 31st bit is positive. So if I turn it on the left side, it is going to be negative. Okay, yeah, so it became negative number. And this is another example where we have shifted. There I have made a shift operator where we are shifting 3 bit. Here I have taken a big number, so I have shifted it 25 bits on the right side. So, and that has become 32. So that's how it is. So examples I have mostly taken with one bit left or right. So you can take any number, any unsigned integer number. Okay, if you take sign, it is always going to be 0. You can try that out yourself. Okay, so yeah, this is how it is. So if it is helpful to you, if you liked it, then please smash the like button, share it with your friends, and if you like similar content again, then click the bell icon for similar videos in the future. Thank you for watching.